Rainbow 6000, a catapult made of popsicle sticks, a binder clip, a bottle cap, and glue. It features a variety of colors, a 15.24 centimeter long arm, a bucket, and a 12.7 centimeter high and 15.24 centimeter wide body. The catapult's body keeps the whole structure stable. The body is also attached to the crossbar, which stops the arm abruptly and releases the projectile at a high angle. The catapult's arm launches the projectile. It's attached to the bucket and binder clip. The catapult's bucket holds the projectile until it's launched. Without it, the projectile would just roll down the arm. The objective of this project was to build a precise and accurate catapult that would launch a projectile with enough force to knock over a tower. All from a distance of 1.52 meters from the tower, I tested 3 different variables to determine which would be the most forceful, force being my dependent variable. The first independent variable I tested was height. The different heights I tested were 0 meters, 0.15 meters, and 0.3 meters. After I tested, I determined that 0.3 meters high was the most forceful, knocking down all 21 blocks. During this launch, the projectile traveled at a distance of 1.52 meters in 0.28 seconds, equaling a velocity of 4.23 meters per second forward. Then I tested my second variable, the catapult arm length. I built 2 more catapults with different arm lengths, but the same structure as the Rainbow 6000 because structure was a control. So if I changed it, I would have gotten inaccurate data. The Rainbow 3000 had a 7.62 centimeter long arm, and the Rainbow 4500 had an 11.43 centimeter long arm. I determined that the 15.24 centimeter long arm was the most forceful, knocking down once again all 21 blocks. Last, I tested the length of arm pulled back. The 3 lengths I tested were 8.89 centimeters back, 12.7 centimeters back, and 16.51 centimeters back. The most forceful launch was when I pulled the arm 16.51 centimeters back. This launch knocked 13 of 21 blocks over. So with that data, I determined the most forceful catapult was pulling a 15.24 centimeter long arm all the way back and launching the projectile from 0.3 meters up. Surprisingly enough, the Rainbow 6000, the first catapult I built, was the most forceful, so I didn't have to change anything I had already built. Now let's talk about the science behind the magic. The purpose of the binder clip was to add elasticity to the arm so more force was applied when the projectile hit the tower. The more elasticity, the more chemical energy that is required from your muscles to pull the catapult's arm back. That chemical energy is then converted into mechanical energy, which is stored within the arm as potential energy because relative to the catapult, it's not moving. So when you release the arm, that potential energy transfers to the projectile as it's being launched. And while it's in the air, the energy converts to kinetic energy because it's in motion relative to the catapult, which is what causes the tower to knock over when the projectile hits it. Throughout this process, no energy was created or destroyed, it only changed form, therefore proving the law of conservation of energy right. Newton's laws of motion can also help explain the science. Newton's first law of motion relates to the catapult and projectile because while the projectile is in the bucket, it is at rest and remains at rest until I pull the arm back and release it to send the projectile forward. And when I do shoot the projectile forward, it would remain in motion in the air if gravity wasn't acting upon it to bring it towards the ground, or if the force from the tower didn't stop the projectile from staying in motion. Newton's second law of motion relates because the more I pull back the arm of the catapult, the more force will be applied to the projectile, therefore causing it to accelerate at a greater speed when I release the arm. Newton's third law of motion relates because the action of me pulling back the arm of the catapult and applying a lot of force means when I release the arm and send the projectile forward, it will have an equal amount of force to knock down the tower because the projectile had an equal yet opposite direction reaction. Forces involved in the process of the catapult launches and hitting the tower are gravity, friction, and balanced and unbalanced forces. Gravity is involved because when you launch the projectile from a higher height or with a more arched launch, not only do you have the force from the arm of the catapult applied to it, but you also have gravity acting upon the projectile as well. However, even if there was no gravity, the projectile would the projectile would still eventually stop moving because of the fluid friction from the air against the projectile, which is another type of force involved. When you pull the arm back, you are experiencing a balanced force because the force from your hand and the binder clip's force is equal, but acting in different directions, equaling a net force of 0 and causing the arm to remain still. But when you release the arm, only the binder clip's force is being applied. So an unbalanced force occurs because the arm is flung forward. Thank you so much for listening.